If we draw two parallel lines and cross them with another line called a transversal, then we'll form a number of angles where the transversal intersects the parallel lines. In this video, we explore the relationships between pairs of these angles, like this pair of corresponding angles. These angles are on the same side of the transversal, facing out in the same direction. Corresponding angles on parallel lines are equal. If we trace out these angles, we see they're just a translation of each other, making an F shape. This pair is also corresponding and so equal, facing out in the same direction and tracing out an upside-down F shape. And there are other corresponding pairs, like these and these, each pair facing out in the same direction and tracing out an F shape. Another important angle relationship on parallel lines is alternate angles. These angles sit between the parallel lines on opposite sides of the transversal. Alternate angles on parallel lines are equal. When we trace out these angles, we get a Z shape. This pair are also alternate angles, and trace out a skewed Z shape. The other pair of angles we'll be using on parallel lines are co-interior angles. These angles sit between the parallel lines on the same side of the transversal. Co-interior angles on parallel lines add to 180 degrees. When we trace out these angles, we get a C shape. This pair on the other side of the transversal are also co-interior angles, and they trace out a backwards C shape. Whenever we see a line crossing a pair of parallel lines, we'll want to look out for pairs of these angles. For example, here's a pair of corresponding angles, and so this pair are equal. Here is a pair of alternate angles, and so this pair are also equal. And this pair are co-interior angles, and so they add to 180 degrees. Let's apply these relationships to solve problems, like this one, which includes two parallel lines shown by arrows, and two known angles. How do we calculate angle D? We first identify these corresponding angles on the parallel lines that trace out an F shape. Since corresponding angles are equal, angle X is also 72 degrees. With this angle marked on the diagram, we can now focus on this triangle. The angles in a triangle always add to 180 degrees. So by subtracting 40 and 72 from 180, we're left with angle D, which is 68 degrees. And we can show our working, giving the geometric reason used at each step in abbreviated form. In this problem, the arrows tell us that PQ is parallel to RS, and the tick marks show us length PR is equal to PS. If we know angle QPS is 55 degrees, how do we calculate angle RPS? First, we can isolate these alternate angles, which means this angle, PSR, is also 55 degrees. With this angle marked on the diagram, we can now focus on this triangle, which, because of the equal length sides, is an isosceles triangle. And the base angles of isosceles triangles are equal, so this angle, SRP, is also 55 degrees. These two base angles add to 110 degrees, so we can use the angle sum of a triangle to work out the third angle. Subtracting 110 from 180 gives angle RPS as 70 degrees. And here's our working with the abbreviated geometric reason used at each step. Finally, in this example we have two parallel lines and two known angles on those lines. We need to find angle B. Now there are different ways to get to the answer, but we can start with this pair of co-interior angles, which add to 180 degrees. So that means angle A is 60 degrees. We can also look for a relationship involving the 110 degree angle, like the angles on a straight line that add to 180 degrees, meaning angle C is 70 degrees. With these angles marked on our diagram, we can now isolate this triangle and use the angle sum of 180 degrees to work out B. The two bottom angles add to 130 degrees, and subtracting this from 180 gives angle B as 50 degrees. And we can summarize our working by showing the geometric reason we used at each step in abbreviated form.